Okay, pre-calculus, we are on the third day of sequences and series in our unit. So a geometric sequence, we're going to go over those today. Geometric sequence is a sequence in which the ratio between the consecutive terms is constant. So in other words, you multiply by the same number to find the next term. So we have recursive and explicit formulas. A recursive formula, you usually get one or sometimes two of the beginning terms, and then you have to write out every single term of that sequence until you get the one that you want. With an explicit formula, you can go ahead and jump ahead to the specific term that you want. It depends on what information you're given. So let's go with example one. First we have to determine if the sequence is even geometric. So basically you just have to look and see, can I find a number where I take a term and I multiply it by the same number each time and I get every single term in the sequence? In A, the answer is yes, because if I multiply 2 by -3 and then -6 by -3 and so on, I'll get the next term in the sequence. So, so the answer to A is hold on. It's yes, and they're also showing you the ratio is -3. So for B, I start with 1, I multiply by 2, and I get 2. And then when I multiply again by 2, I'm not getting 6. So that is not going to be geometric. For C, if I rewrite this as 1 using my algebra properties, exponent properties, this is 2 to the n, I could rewrite this as 1/2 to the n power. And then you can see the terms are 1/2, 1/4, 1/8, 1/16, and that's for, n is 1, 2, 3, and 4. And then you can see, yes, that is going to be geometric because r is equal to 1/2. I can take 1/2 and just multiply it by, each term I can multiply by 1/2 and get the next term. All right, so for n equals 1, 2, 3, and 4, I get 1, 8, 27, and then 64. So that is no. That's a big no for geometric. Example 2, find a particular term of a geometric sequence. So we're asked to find the 9th term of the geometric sequence. So let's go ahead first, and we notice that, all right, what am I doing here? What am I multiplying by to get each of the next terms? It looks like it's going to be 10. If I multiply by, that's a multiplication sign there, by 9/10, I'll get 9. So r is equal to 9/10. So here's my formula, and I'm going to go ahead and plug in, look for the 9th term. The first term is 10. A sub 1 is 10 times, now I need to multiply by r, not 9 times, 9 minus 1 times. So that, let me write that out. So that's 9/10 for r to the 9 minus 1, so that's 8. Take out your calculator and you get, I'm writing this down. This is what I got on my calculator. How many zeros is that? Good enough. Okay. B. So find the 8th term of the geometric sequence. So I go ahead and throw my 8 in. So I'm a sub 8 equals first term, 24, to the times -1/2 to the, that's going to be 7th, because it's n minus 1. And the way we got the first term, this 24, is if I go ahead and plug in 1 for n, I get, this is to the 0 power. Anything to the 0 power is 1, so it's just going to be 24 times 1, 24. And then you will get, if you don't get a fraction, just use math enter, but you should get -3/16. Okay, now we're moving on to summation. The sum of those terms now. We're not just writing out the terms, we're going to sum them, add them all up. The sum of the first n terms, we could use this formula. So find the sum of the first 5 terms of the sequence. So a sub 1 is the first term, that's 1/3. And it turns out that r also happens to be 1/3. So let's just follow the formula here. 1 minus r to the n over 1 minus r. You just take out your calculator and you should get 121 over 243 if you put that in correctly. press pause and make sure you can do that, because you need to know how to enter things into your calculator and using parentheses and stuff. All right, an infinite geometric sum can be found by using the absolute value of r has to be less than 1. Basically, if I put a value in my denominator here that's, you know, above 1 or above -1, I'm going to end up with a value where my numbers keep getting bigger and bigger. We want to find an infinite geometric sum, if possible. So basically, these numbers just can't go up exponentially. They've got to converge to a particular number, so there is a sum. If they don't get smaller to a sum, then there's no sum, which is why this is important to check first before we start. So we go ahead and we'll start with example number 4. So first you got to find r, and r in this case is 2/3. And then we check, is the absolute value of 2/3, is that less than 1? Yes, so we're good. Now we use the formula. The infinite sum of, and now we want a sub 1, which is 2, over 1 minus 2/3, and you got to type that in the calculator correctly, or do it by hand. Either way, you end up with 6. So there we go. When you try b, you get r is 4/3. Well, the absolute value of 4/3 is not less than 1. It's greater. So those numbers are going to keep going up. 12, and then 16, 64/3. It's not going to converge to a particular number or a sum. So this is just no sum. You can stop right there. Moving to example 5, if you're asked to write a repeating decimal as a fraction in lowest terms, you want to separate that repeating fraction into decimals and add them together with a ... at the end. When you do that, rewrite them as fractions and then as powers of 10. And when you do that, now you can see that r is going to be equal to 1 over 10 squared. We've got clearly the absolute value of 1 over 100, or 1 over 10 squared, is less than 1. So check, we're going to have a sum here. And now we just throw that in the formula, and we get the infinite sum of, and this is first term, 0.36 over 1 minus r. And we get 36 over 99. There you go. This is a special case here for B, but I think it's just important to see. When you do the same process, it actually turns out that 0.999 repeating, it's got to have the ... at the end, is actually equal to 1. And let me show you. I pulled these off the internet. If you try these on your calculator, you will see you're going to get the same thing. And you can take a look at these and pause this and see. This is a system of equations here. You can watch more videos online. You can search reasons why 0.999. It's actually not 0.999. It's ... at the end equals 1. It has to be non-terminating. All right, so to generate a sequence, just how to do this on the calculator. Okay, so you actually don't need to do this anymore. This is an old, it's from before the update. So let me turn my page here so I can get the numbers to type in. Okay, so for example, if we want to put in a sequence, right, we go to second, stat, and then we go over to ops, and then option 5 is sequence. Then now with the way this is set up now, before it used to look like this, where you had to type it in to the side. Now it's got everything kind of all filled out for us in the calculator with the new update. So the expression is, which one are we doing? 2 parentheses 3 to the n minus 1. And we're just going to use x. You're going to always do that. The variable is x. Start is usually 1. It usually goes from 1 to, and I think this problem ends at 10. I hope it does. I think I wanted, the 10th sequence, yes. Okay. And then I think that's all we need. And see how it pastes it in for you? Before, we had to type it in that way. And that was, you just forgot a parentheses or a comma or something. It was just crazy. But there you go. So it just gives you, something is wrong. Oh, there we go. That -1 did not go back into the exponent. Let's try that again. Second stat ops 5. Let me fix this exponent. Parentheses x minus 1. Now the calculator knows that entire thing, that entire quantity, is an exponent. Better. See the difference? Press enter, different answers. And then if you want to scroll to the right, you can get, shouldn't that work? Yeah, you should be able to just arrow to the right. You can see more numbers. For summation, you can press math and then 0. And it will give, and you have to use x, no matter what variable they use. And let's just make some stuff up. Let's say we go from 1 to 10, and then you have to put the entire expression here, even the exponent. Okay, so let's say we're doing the same thing. 2 parentheses 3 parentheses to the x minus 1. X minus 1. Notice how nicely it goes there. We don't have to worry about putting the parentheses like we did for the sequence. But the parenthesis, the exponent has got to go inside that parentheses. You cannot use this parentheses and put the exponent on the outside of it. So there's how you do that on the calculator. And you go back to the notes and make sure I'm finished. Yes, I am. That is all. Peace out.